In this lecture, we'll be studying about shared memory systems. In the previous lecture, we studied about interprocess communication, where we saw that shared memory systems and message passing systems were two ways in which interprocess communication can take place. So in this lecture, we'll be seeing in a more detailed way about shared memory systems, and we will see what are these features and how it actually works. So here we have a diagram of the shared memory system, which is the same kind of diagram that we saw in the previous lecture. So here we have process A and process B, which wants to communicate to each other. That means center-process communication has to take place. And in order to do that, the shared memory system has to be used. So here a region of shared memory is established. And using this region of shared memory, process A and process B will communicate to each other. So that means process A will write whatever it needs to communicate to process B to this shared memory region, and process B will read from this shared memory region whatever process A has written and whatever process A wanted to communicate to process B. So it says here, interprocess communication using shared memory requires communicating processes to establish a region of shared memory. So that is what I just told you over here. Whenever process A and process B, or whenever two or more processes wants to communicate to each other using the shared memory system, they need to establish a region of shared memory, like the one shown in this figure, so that using the shared memory, they can communicate with each other. So this region is shared between process A and B, so that whatever process A puts here, B can read from here, and whatever B puts here, A can also read from here, and then typically, a shared memory region resides in the address space of the process, creating the shared memory segment. So we may think that, where does this shared memory region actually reside, or where does it lie? So the answer to that is, the shared memory region resides in the address space of the process creating the shared memory segment. So in this example, we have process A, which wants to communicate to process B. So process A will create the shared memory region, and it will lie in the address space of process A. This shared memory region will lie in the address space of process A. That means process is the one who wants to initiate the communication. So the shared memory region will be created in the address space of the process creating the shared memory segment. So the shared memory segment is created here by process A. So the shared memory region lies in the address space of process A. So that is what we mean by this point. So moving on, other processes that wish to communicate using this shared memory segment must attach it to their address space. So what is the other process that wants to communicate? Here it is process B. So if process B wants to communicate, then what it has to do is, it has to attach the region of shared memory that was created by process A to its own address space. That means the shared memory division is created by process A, which will initiate the communication, and process B must also attach this region of shared memory to its address space, so that we can say that this region is shared between process A and process B. So that is what we mean by this third point. So normally, the operating system tries to prevent one process from accessing another process's memory. So normally, the operating system, it does not allow one process to access the memory of another process. So in normal condition, process A cannot access the memory of process B, and process B also is not allowed to access the memory region of process A. That is not allowed by default in the operating system. But if shared memory system has to be executed, then shared memory requires that two or more processes agreed to remove this restriction. So what was the restriction? So the restriction was that one process's memory cannot be accessed by another process. But if we want shared memory systems to work, then the processes that are going to communicate must remove that restriction, in which operating system does not allow the memory of one process to be accessed by another process, because this share region, as I already told you, is created in the address space of one of the process. So this process B should be able to access this, which is the memory region of the other process, and vice versa. So if that is not allowed, then they will not be able to access this region of shared memory. So that is why it says, the shared memory requires two or more processes agree to remove this restriction so that they can share and access this shared region of memory. So those were some of the important points that we need to remember about the shared memory systems. So the region of shared memory is created by the process initiating the communication. And remember that the operating system itself does not interfere in creating the region of shared memory. Where the region of shared memory has to be created, it is decided by the processes that are going to communicate with each other. So in order to understand this shared memory concept, we can take the example of producer-consumer problem. So this is a classical problem that is there in operating system. It is known as a producer-consumer problem, in which a producer process produces information that is consumed by a consumer process. So there are two processes, in which one is known as the producer, and the other one is known as the consumer. So what the producer will do, it will produce information. And what will the consumer do? It will consume the information that is produced by the producer. For example, a compiler may produce assembly code which is consumed by an assembler. The assembler in turn may produce object modules which are consumed by the loader. So in the first part of the example, the compiler is the producer and the assembler is the consumer. And in the second part of the example, the assembler is the producer and the loader is the consumer. Alright, so we can also explain this example using the client-server model. So supposed, let's say that you are accessing the internet. So in that the client is accessing the server. So the server is a producer, which is producing web pages or HTML files. And the client is the consumer, which is consuming those files produced by the server or the producer. And how is it consuming? It is a reading, or it is accessing that. So that is the producer-consumer problem. Now what is the actual problem? In this producer-consumer problem, we need to make the producer and consumer to work concurrently. So the producer will produce and the consumer has to consume, and they have to work concurrently so that the consumer will only consume what is produced and will not try to consume what is not produced. And in that way they have to work concurrently. So let's see, what is the solution to this producer-consumer problem? Or how can we make this producer and consumer to work concurrently? So obviously, one solution to the producer-consumer problem uses shared memory. So shared memory, which we have discussed just before, is one of the solution to this producer-consumer problem. And how is that? To allow producer and consumer processes to run concurrently, we must have available a buffer of items that can be filled by the producer and emptied by the consumer. So in order for the consumer and producer to run concurrently, we should have something called the buffer, a buffer of items. A buffer is a place in which the producer can produce the information and it can be filled in that place. So the buffer will be filled by the information produced by the producer, and consumer will consume from the buffer and empty the buffer. So we can think of the buffer like the shared memory, the region of shared memory. So in that region of shared memory, or the buffer, the producer will produce and keep the items or the information, and then the consumer will consume from that buffer, and then this buffer will reside in a region of memory that is shared by the producer and the consumer processes. So this is I already said, this buffer, where the producer will produce and from which the consumer will consume, will reside in a region of memory that is shared by both the producer and the consumer processes, so that they can both access that region of memory, and hence they can work together. A producer can produce one item while the consumer is consuming another item. So the producer can produce one item and keep it into the buffer while the consumer is consuming another item from that same buffer. And the producer and consumer must be synchronized so that the consumer does not try to consume an item that has not yet been produced. So the producer and the consumer has to work in synchronization with each other so that the consumer will not try to consume something which has not yet been produced. It can only consume things that has already been produced by the producer. So if it tries to consume something that has not yet been produced, then there will be error. So it should only consume things that has already been produced. So in that way, they must work in synchronization with each other. So this can happen with the use of this shared memory. And in this region of shared memory, we'll have the buffer of items, where the producer will produce, and from which the consumer will consume. Now, we have talked about the buffer, in which the producer will produce, and from which the consumer will consume. And there are two kinds of buffer that we need to learn about. So the two kinds of buffers are unbounded buffer and bounded buffer. So these are the two kinds of buffers that we have. Now let us see what is unbounded buffer and what is bounded buffer, and how do they differ from each other. In this unbounded buffer, it places no practical limit on the size of the buffer. The consumer may have to wait for new items, but the producer can always produce new items. So, in this unbounded buffer, there is no limit on the size of the buffer. It's like a buffer with unlimited size. That means if it has unlimited size, the producer can keep on producing items. It does not have to stop or wait. As long as it can produce, the producer can keep on producing items because the buffer will not become full. It is an unbounded buffer. It has no limit on the size, so the consumer may have to wait for new items. The consumer may have to wait for new items only when the buffer is completely empty. That is when the producer has not yet produced anything, or if the consumer has consumed everything and the producer has not produced any new items. So the consumer will have to wait only when the buffer is empty. But in case of the producer, it can keep on producing the items because there is no limit on the size of the buffer. So that is what we mean by unbounded buffer. Now let's come to the next one, bounded buffer. So in this bounded buffer, it is just opposite of unbounded buffer. It assumes a fixed buffer size. In this case, the consumer must wait if the buffer is empty, and the producer must wait if the buffer is full. So unlike unbounded buffer, this bounded buffer, it has a size limit. It has a fixed buffer size, so it does not have unlimited space. There is a limited fixed buffer size. And in this, what happens? The consumer will have to wait if the buffer is empty. So similarly, like the unbounded buffer, even in the bounded buffer, the consumer will have to wait if the buffer is empty. If the buffer does not contain any items, and the producer must wait if the buffer is full. So since there is a limited size or a fixed size in this buffer, the producer will also have to wait if the buffer is full. So in unbounded buffer, the producer never had to wait because it can keep on producing as there is no limit on the size. But in bounded buffer, since there is a limit on the size, the producer will have to wait if the buffer is full. It will have to wait for the consumer to consume some of the items and make more space so that it can produce newer items. So that is bounded buffer. So those are the two kinds of buffers that we have in the producer-consumer problem. So remember that this buffer resides in the region of shared memory, where both the producer-consumer can access, and we are discussing all this because this is an example of the shared memory systems. So what we are actually discussing is interprocess communication and the ways in which interprocess communication can take place. So we discuss about shared memory systems, and we saw how it works. And in order to explain that, we took the example of the producer-consumer problems, and we saw the two kinds of buffers that are available in the producer-consumer problem. So with this, I hope the concept of shared memory systems are clear too. Thank you for watching, and see you in the next one.